Good morning, everyone. Let us start this session. So today we will start the module number 2, which is the equilibrium. So it is an equilibrium of co-planar forces and the beams. Okay. So module 2 has two sections. Section 2.1, it is about the equilibrium of system of co-planar forces, and the section 2.2, it is about the equilibrium of beams. Okay. So in the section 2.1, which is the equilibrium for the system of coplanar forces, we have the conditions of equilibrium for concurrent forces, for parallel forces, and for non-concurrent, non-parallel general forces, okay, and couples. Then equilibrium of the rigid bodies. Okay, so we will study the free body diagram. So in the first module, we have already discussed what is meaning of a free body diagram. Okay. And after that, in the 2.2, we have the types of beams, then simple and the compound beams, types of supports and the reactions, then determination of reactions at the supports for various types of loads on the beams. Okay. So we will see all the points one by one. Okay. So first we will see what is meaning of equilibrium. When the resultant of a force system becomes zero, the system is said to be in the state of equilibrium. Okay. So equilibrium can be the static equilibrium or dynamic equilibrium. So for the equilibrium, system offers the reactions to the applied forces to maintain that equilibrium. Okay. So in the static equilibrium, we have the examples of buildings, dams, railway bridge, then lamp hanging from the ceiling, then book kept on the table as shown in the figure. And the dynamic equilibrium, it means object moving in the space at the constant velocity. Okay. So basic concept of the equilibrium is it is the balance state for a system. Okay. So for the equilibrium, system offers the reactions to the applied forces, okay, so that it can maintain the equilibrium. Okay. And in the first definition, when the resultant of the system or a force system, it becomes zero, the system is said to be in the state of equilibrium. Okay. So in the first module, we have studied how to find out the resultant of the system. Okay. So resultant means it is the net effect of all the forces on the system. Okay. So we replace all the forces by a single force, that is called as a resultant. Now, if you want the system to be in the state of equilibrium, okay, then this resultant, its value, it must be zero. Okay. So when this condition is possible, if the system offers the reactions to the applied forces, then we can say the system is in equilibrium. So observe the first example. Okay. So in this example, there is one book which is kept on the table. Okay. So this book, it will have the weight. So this is the weight vector, that is a WB. Now to balance this WB, this wooden board or this table, it will offer some reaction. Okay. So reaction means the opposite force to the applied force. So here applied force is nothing but the WB, that is the weight of the book. Okay. So to maintain the balance state, this table will offer the opposite force, that is called as a reaction. Okay. So here, in case it is a normal reaction, that is a reaction is exactly perpendicular. Okay. So this normal reaction, it will oppose the applied force WB. Okay. So we can write the equation, the NB, that is a reaction offered by the table, it must be equal to WB. Okay. So in this condition, if you add these two forces, okay, so NB is in the positive direction and this will be minus WB. Okay. So this addition, it will be zero. Okay. So what is meaning? the net force on the system, this is 0. Okay, so this condition is called as a resultant is 0. Okay, and if the resultant is 0 or net force is 0, that means system is in the state of equilibrium. Okay, so in the second example, you can see the applications of equilibrium. Okay, so this bridge, it is supported, or this weight of the road is supported with the help of the columns. So these columns will offer the reaction to the applied forces. Okay, so these are the forces due to the weight of the cement concrete or the weight of the vehicles. Okay, so these weights must be balanced by the reactions. Okay, so that the resultant will be 0 for the system. Okay, so each column will offer certain reaction in order to nullify the effect of these downward forces. Okay, and then net effect, that is the resultant of the system, it will be 0, so that the system will be in the equilibrium. Okay, so right now just imagine, for the static condition, that is to maintain the static condition, the net effect of the forces, it must be 0. Okay, so this is called as a equilibrium condition. So now we will discuss, to maintain the equilibrium, what are the mathematical equations. Okay, so each system has to satisfy this certain equation so that it can maintain the equilibrium. Okay, so here I have shown two examples. Okay, so both these systems, so these are the concurrent force system. So first we will see the conditions of equilibrium for concurrent force system. Okay, so from the definition of equilibrium, okay, we know that for the equilibrium, resultant has to be 0. There should not be any net force on the system. Okay, so for concurrent force system, suppose this system, this is the concurrent force system. Okay, so if you draw the free body diagram for this system, so here you must know the concept of free body diagram. So we have already discussed this in the first module. So what is free body diagram? You will isolate the object from its surrounding, and then you will show all the forces and the reactions acting on that object. Okay, so here at point B we have three forces. Okay, one is force in the cable BC, second is force in the cable AB, and then force BD. Okay, suppose this is one object. Okay, so this object is hanging at point B. So for the force analysis, you will isolate this point B. Okay, so just draw the point B. And then the cable BC means there is one tension force. So let us take this tension BC. Second is tension AB, or this is tension BA. And at point B, there is one object. Okay, so this object, it will have some weight. So this is the WD, that is the weight of the D object. Okay, so this is called as a free body diagram. Okay, so in the free body diagram, we will show the forces or the reactions. Okay, so for the concurrent force system, what are the conditions of equilibrium? Suppose if you want to find out the resultant of the system for the concurrent force system, then its equation is R, this is equal to summation fx square plus summation fy square. Okay, and equilibrium means resultant must be 0. Okay, that means we should equate this equation to 0. Okay, and then we can say this concurrent force system, it is in the equilibrium. Okay, there is no resultant in the system. So in order to make this equation 0, both these terms must be 0. Okay, that is means summation fx has to be 0 and summation foi has to be 0. So for the concurrent force system, we get the conditions of equilibrium as the first condition of equilibrium is summation fx must be 0. Okay, that is a summation of all x component in the of forces. And second condition is summation fy, it must be 0. Okay, so these are the conditions of equilibrium for concurrent force system. Okay, so if any system it satisfies these conditions, then that system it will be in the state of equilibrium. Okay, so you note down these conditions. So this is the first force system, which is the concurrent force system. Okay, then second system, which is the parallel force system. Okay, so suppose we have one rod AB. Okay, so parallel force system, here we have one rod AB. Okay, or you can consider this is one table. Okay, so these are the two supports of that table. So C and D. Okay, and two persons, they are sitting on this table. So here the person 1 has weight W1 and second person has weight W2. Okay, and their distance with respect to this support C and D. So this is L1, this is L2. Okay, and this distance is L3. Okay, now for the parallel force system, we know that the resultant, just recall the concept from the first module for parallel force system. So resultant is given by this equation, summation fy only if all the forces are in y direction. Okay, and resultant r, this is equal to summation fx if all the forces are in the x direction. Okay, so now for this system, all the forces W1 and W2, they are acting in the y direction. Okay, so in this system, W1 and W2, these are not the only forces present in the system. Okay, two more forces are there in the system. Okay, and these forces are nothing but the reactions offered by the supports. So here at point C, we have one support. Okay, so this support is a RC. At point D, the support is RD. Okay, so actually these are called as a reactions. Okay, reaction RC and reaction RD. So in order to visualize these reactions at point C and D, we should draw the free body diagram. Okay, so for the free body diagram, just isolate this AB. Okay, so just you should draw So this is the AB. So this may be a wooden plank. Okay. Then at point C, just draw the vector RC. Okay. That is nothing but there is one support, and this support, it offers the reaction RC. Then at point D, we have the reaction RD. Okay. So it will represent this support, and the applied forces are nothing but the weight W1 and second is weight W2. Okay. So this is called as a free body diagram. Okay. That means we have isolated the rod AB. Okay. And then we show all the forces and the reactions on this rod AB. Okay. So this free body diagram, it is useful for the calculation of reactions. Okay. So then you can show the distances. So this is L1. This is L2. So this is C point. This is point D. And this is the L3. Okay. Now just imagine this system, it is in this state of equilibrium. So it is in perfect equilibrium. Okay. So in order to maintain that equilibrium, we need to make this R is equal to summation Fy 0. Okay. So basic concept of equilibrium is resultant has to be 0. Okay. So if resultant is 0, then this summation Fy, it must be 0. Okay. So for the parallel force system, the first condition of equilibrium is if all the parallel forces are in y direction, then the summation Fy, it must be 0. Okay. In the same, if all the forces are in the x direction, then summation Fx, it must be 0. Okay. So these are the two conditions of equilibrium. Okay. So these are just for forces. Okay. Now here you can observe, suppose this W1 is given. Okay. Let us take this 10. W2 is also 10. Consider this is in Newton. This is in Newton. Okay. And the question is, and also these distances are given. Let us take this L1 as a 1 meter. L2 is 1 meter, and even L3, this is 1 meter. Okay. And question is, find out the values of support reaction. Find support reaction RC and RD. Okay. So if you observe this free body diagram, then you have two unknowns. One is RC and second is RD. Okay. So for the two unknowns, you must have two equations. Okay. So two unknowns you can find out by using two mathematical equations. But if you observe these conditions of equilibrium, okay, so which condition we can apply for this type of system? Okay, that is a system shown in for this free body diagram. Only one condition we can use. That is a summation Fy is equal to 0. Okay. But we want to find out two unknowns. One is RC and second is the RD. Okay. So we must have the second condition. Okay. We cannot use summation Fx0 because there is no force in the x direction. Okay. So what is the second condition? So second condition for such type of system, that is a parallel force system, is the summation of moment at any point of the system by the forces and the reactions in the system, it must be 0. Okay, so this is the second condition that you can use for parallel force system. Okay, so for this problem, if W1 is given, W2 is given, all the distances are given, and question is find out the RC and RD. So as we have two unknowns, so first condition we will use summation Fy0. Okay, so by using this condition, you will get one equation in terms of RC and RD. Okay, and second condition you will use summation of moment at any point of the system. It must be 0 if the system is in state of equilibrium. Okay, so this is your second condition. So for the parallel force systems, so you can note down these conditions. First condition is summation Fx0. Second is summation Fy0. Okay, and your third condition is summation of moment. This is equal to 0. Okay, so if the system is parallel force system, you can use out of these three conditions, you can use any two conditions. Okay, so two conditions will be summation Fx0, summation moment 0, or summation Fy0 and summation of moment 0. So this condition will be common. Okay, so you must use summation moment 0 for parallel force system. And if the forces are horizontal, that is along x direction, use summation Fx0. If forces are vertical, then use summation Fy is equal to 0. Okay. Okay, so let's try to solve the previous example and then we will understand how to use this condition. Okay, so this is the table and these are the supports. Support is C and D. Okay, and we have the two weights. So this is a 10 Newton. This is also 10 Newton. Okay, and the distances are 1 meter. Okay, so question is calculate the reactions at support C and D. Okay, so your first step when we solve the problems on the equilibrium, it may be a concurrent force system or the parallel force system. You should draw the free body diagram. Okay, so by free body diagram, you can visualize all the forces and the reactions on the system. So just isolate the rod AB. Okay, because the rod AB is subjected to reaction and forces. Okay, so you should show the forces as it is. So this is a 10 Newton. This is 10 Newton. Then these supports, they will offer the reaction exactly in the upward direction. So this is the reaction RC and this is the reaction RD. Okay, and distances are 1 meter. This is point C, A, B and D. Okay, use the first condition. Summation Fy is equal to 0. Okay, because you cannot use summation Fx0. So by using this condition, you will get the equation as for summation Fy 10 Newton and this 10 Newton in the downward direction. So it is minus 10 10 minus 10, RC and RD in the positive y direction. So plus RC and plus RD. Okay, so this is equal to 0. So from this you will get the equation as RC plus RD. This is equal to 20. Okay, so this is your equation 1. Now the second equation you will use as the summation moment is equal to 0. Okay, so summation of moment by all the forces and the reactions. Okay, you can select any point of the system, A, C, D, B, or any intermediate point. Okay, but as the distances they are given with respect to point C or with respect to point D. Okay, so you can select either C point or either D point. So take moment point as a point C and equal to 0. So this is equation summation of moment 0. Okay, now take the moment at point C by all the forces. So the first moment by the reaction RC about the point C. So as the reaction RC is passing through the point C only, so its moment is 0. Okay, so we will not consider the reaction RC for the moment equation. Okay, the next is 10 Newton. So 10 into, now this is the perpendicular distance for 10 Newton with respect to point C. Okay, so that moment it is in the clockwise direction. Okay, so this moment will be minus 10 into perpendicular distance is 1 meter. Okay, next is 10 Newton and the total distance is 1 plus 1. So this is 2 meter and force is 10. So this is 10 into 2. And again this moment it is clockwise direction about the point C. So this is minus. So remember all the distances we are measuring with respect to point C only. And next is reaction RD. So for the reaction RD, total distance from point C is 3 meter. Okay, and this moment it is in the anti-clockwise direction, so it is positive. So plus reaction RC into reaction RD into 3 meter. Okay, equal to 0. So this is your complete moment equation about the point C. Okay, now from this equation you can write this 3RD. This is equal to, so this is minus 10 and this is minus 20, so it is minus 30. On the right hand side this is a plus 30. Okay, and then you will get the reaction RD. This is equal to 10 Newton. Okay, so this is the first unknown value that we get from the moment equation. Okay, now this value you can substitute in the equation 1. So you will get the reaction RC as, so this is RC which is a 20 minus reaction RD. So this is again 10 Newton. Okay, so by using these two conditions of equilibrium for the parallel force system, you can find out the two unknown reactions. Okay, so this is the use of equations of conditions of equilibrium. And the third type of system, which is the non-concurrent and non-parallel, which is called as a general force system. Okay, so for such type of system, forces will act at the different point of the system and in the different directions. Okay. So suppose we have the rod AB, and on this rod AB, we have the forces like F1, F2, F3. Okay. And there is one moment, that is a couple present in the system. So let us take this couple as a M1. Okay. And all these forces and this couple, they are supported by the two reactions. So suppose the reactions are at point A. So this is the RA, and at point B. Okay. So for this system, so just recall the resultant of general force system. So for general force system, we write the equation R is equal to summation Fx square plus summation Fy square. Okay. So if you want the resultant to be 0, then summation Fx, it must be 0, and summation Fy, it must be 0. Okay. So these are two basic conditions for the general force system. Okay. And sometimes you need to use this condition. Summation of moment, it should be 0. Okay. Then the system will be in perfect equilibrium. Okay. So for non-concurrent, non-parallel force system, we have the conditions like summation Fx0, summation Fy0, and summation of moment 0 at any point of the system. Okay. So these conditions for non-concurrent, non-parallel force system, they are similar to the parallel force system. Okay. Okay. So now we will discuss in detail the concurrent force system with the help of one example. So equilibrium of the concurrent force system. So you can note down this: a lamp of weight 150 Newton is supported by two cables as shown. Okay. And the question is, find the forces developed in the cable. Okay. So the system given is one lamp is hanging from the ceiling. Okay. So it is supported with the help of cable AC and cable BC. And this inclination of the cable AC, this is given as a 3-2, and this inclination, it is given as a 8-3. Okay. And we have to find out the forces in the cable AC and the force in the cable CB.